The skeleton coast of Namibia, endless miles of dry desert, rough seas, and a desperate shortage of fresh water. It is one of the harshest environments in the world. Fresh potable water is a scarce commodity in this region. Murray & Roberts Marine, Arriva and WSP Coastal Africa designed and constructed the intake and outfall for the largest desalination plant in southern Africa, situated at Vlotskasbaken, Namibia. The desalination plant turns seawater into 20 million cubic meters of fresh potable water every year. The careful design and construction of the intake and outfall pipeline system is one of the most crucial elements of the desalination process. The intake is placed 1,100 meters offshore from the coastline to minimize the effects on the environment and to reduce the amount of sediment in the intake water. From the intake structure, 2 intake pipes are used to deliver seawater from the ocean to the desalination plant. At the plant, the water is pushed through a membrane that only allows the water molecules to pass. The remaining brine solution is discharged back into the sea using an outfall pipe. The discharge point of the outfall is placed 600 meters offshore from the coastline to prevent outfall brine being sucked into the intake again.
The laying of 2.7 kilometres of pipeline in the rough marine conditions isn't an easy task. In addition to the harsh environment, the construction team had to deal with removing a lot of shallow rock in the surf zone to form the trench. The remote location of the site meant that all items used on the construction had to be transported over a great distance, and this was a very challenging logistical operation.
For the installation of the pipeline, a 360-meter long, 7-meter wide trench was required through the surf zone. A temporary jetty and 2 cofferdams were used to facilitate the blasting and excavation of the trench. The temporary works were designed by the Murray & Roberts Marine Design Office in Cape Town, South Africa. The cofferdams not only provided access during construction, but also prevented the breaking waves from filling the trench with sand before the pipe could be installed. A 300-meter-long jetty was constructed off one of the cofferdams, which provided a platform for the excavation of the remainder of the trench. First, a blasting crew used the jetty to drill holes in the bedrock and place the explosive charges. Proper placing of these explosives ensured that the bedrock was fractured up to the required depth and that it was shattered into small pieces. After the blasting, a grab suspended from a crane on the jetty was used to remove the shattered rock in order to open up the trench. 18-meter-long, 1.2-meter diameter steel pipe sections were transported from Johannesburg, South Africa, to the construction site in Swakopmund, Namibia. The pipe sections were placed on storage plinths and moved through the construction line using specially designed hydraulic bogies. The first pipeline sections were welded together in 164-meter-long strings by a specialist welding crew on the welding plinths. The strings were then transported to the concrete weight coating plinths, where 150mm thick concrete weight coating was cast around the pipes. The concrete weight coating protects the steel pipes and prevents the pipe from lifting up from the seabed during storms and rough seas. Finally, the strings were transported to the storage yard, where sacrificial anodes were installed. The sacrificial anodes prevent the steel pipe from corroding in the highly corrosive sea environment. The construction of the intake structure in the form of a caisson was undertaken in a floating dry dock in the port of Walfish Bay, some 60 kilometers south of the construction site. The intake caisson does not only provide a stable seawater intake 4 meters above the seabed, but also acted as a sheave block anchor during the installation of the pipelines. The design of the intake caisson is a good example of the design capabilities of Murray & Roberts Marine. The intake caisson was designed to float during transport, but once placed and stabilized with sand, it needed to have sufficient mass to resist the 600-ton pulling force of the linear winch that was used to pull the pipes into the sea. To ensure that the seawater intake caisson was designed correctly and to ensure that it would be able to resist the pulling force, small-scale physical model tests were carried out at the hydraulic laboratory of the Stellenbosch University. To control the sinking of the caisson in its final position, 4 steel risers were placed on top of the caisson. During a period of calm weather, the caisson was transported out of the sheltered port of Walfish Bay to the open sea. After a 16-hour trip, the caisson arrived at its final position. The caisson was kept in place using anchors, and water was slowly let into the caisson, ensuring a careful and precise placing of the caisson onto the seabed. After removal of the steel risers, the openings between the seabed and the caisson were pumped full of grout, ensuring a good interaction between the bedrock and the caisson. Finally, the caisson was pumped full of sand to ensure its stability on the seabed. The cable used during the pull consisted of 3 pieces. A short piece of cable was installed through the caisson and around a specially designed sheave block at the back of the caisson. The divers connected one side of this short piece to the cable from the linear winch and the other side to the pulling head on the 3 pipes. From the launchway, all 3 pipes were carefully pulled into the sea, string by string, 164 meters at a time. The 164-meter-long pipe strings were welded together on shore before pulling the next string out to sea. The diffuser head of the outfall pipe was disconnected from the pulling wire by divers after the pipes had been pulled 600 meters. The remaining 2 intake pipes were then pulled all the way to the intake caisson. All 3 pipes were then connected to the GRP pipeline, which was connected to the pump station. The pipe was then flooded with water through a valve in the pulling head. The pulling head was then disconnected and removed by the divers. The space between the end of the pipes and the intake caisson was completed underwater by divers installing spool pieces that were connected to the end of the pipes using bolted flanges. The annulus around the spool piece and the intake caisson was grouted up to ensure a closed connection. The shore crossing trench was backfilled with sand. After completion of the works, the construction site was dismantled and every item was removed to ensure that the site was left as it was handed over. The whole pipeline project was completed in 2 years, despite the extreme environmental conditions. The work was completed without any serious injuries due to the enforcement of safety procedures on site. The success of this project is a great example of the contracting and engineering capabilities of Murray & Roberts Marine.